First of all, are there any any questions? Are we all cool? Okay, what we're going to do today is we're going to talk about some of the methods that we actually use to solve the problems in developmental psychology that I talked about last time. So, given that we're interested in figuring out what children think and how what we think changes, what are some of the ways that we could actually go about trying to study it? And we use a lot of different kinds of measures to try to figure out whether a method is actually a good method or not. So one question, of course, is how objective are the methods? So can we make sure that we're not biased by our own preconceptions when we're collecting the data? Another idea is reliability. That's the idea that when, for instance, two different people are conducting a study, they'll come up with the same results. And as we'll see in development, where we often use naturalistic methods, like just observing children, this question of reliability, are two people seeing the same thing, actually gets to be a really important question. Another question is replicability. So when someone else goes and does the experiment, are they going to come up with the same results? And again, that's a really important metric for trying to interpret developmental results. So if someone else does the experiment, will they come out with the same answers? And lastly, how valid are the measures that we're using? So when I do an experiment and I say this is telling me something about what children think, how representative is that of what's really happening out there in the real world? And a particular idea that's often raised in developmental psychology is this idea of ecological validity. So we want to know something not just about how children behave in the laboratory, but we want to know something about what's really going on in children's minds out there in the real world. And often there's, especially for development, there's a big question about whether, say, what a child does in the laboratory with an adult person leaning over them and asking them questions, is that really the same sort of thing that the child would do if the child were just out there in their natural environment? So those are some of the big questions that we can ask about. Those are some of the big questions that we can ask about development. I thought I got that fixed, but evidently not. Okay. So what I'm going to do is I'm going to give you an example of one development in developmental psychology, one set of phenomena and ideas, and that's been the focus of a tremendous amount of attention over the last 20 or 30 years. And then take that one question and show you all the very, very different methods that we can use for trying to figure out an answer to that question. So the question is, when do children understand that somebody else can believe something that's false? So in other words, all of us can, let me give you an example to make this vivid. So for instance, suppose I show you this box of candy, and then I open up the box and there's actually pencils inside of the box. And then I close up the box again. Now, if I asked you guys, suppose someone else who hadn't opened up the box walked into this room right now, saw this closed up box, what would they think was inside it? Would they think that there were pencils inside it, or would they think that there were candies inside it? Candies, hey, good. Okay, you're all above the age of 4. But when you ask exactly the same question to 3-year-olds, then 3-year-olds very characteristically will say the other person will think that there are pencils inside. So 3-year-olds seem to act as if something's true, then everybody in the world will know it. And interestingly, as we'll see in a minute, children with autism also seem to make this mistake even when they're well past the age of 3. So the question is, how can we find out when and how children start understanding this very profound thing about other people, which is that sometimes their beliefs about the world can be false and can be different from your own beliefs. So when can children take the perspective of another person, recognize that another person might have a mistaken view of the world? So that's the big question we're going to ask. And then the question becomes, what could we do to answer that question? Now, in developmental psychology, we have two kind of big categories of ways of answering that question. One of them is to be involved in naturalistic observations, just go out and see what babies and young children are doing, watch what they do. And the other is to try to do systematic experiments. And the naturalistic observations method actually has a long and, so we'll talk about naturalistic observations first. The naturalistic observation method actually has a long and very reputable history. In fact, I was just reading that people like Josiah Wedgwood, of all people, kept diaries of his children's development. William and Dorothy Wordsworth, the great poets, kept diaries of their children's development. And actually, there's a rather sad story, which is that in the middle of the 19th century, there was some fantastic work by a scientist who actually started systematically looking at what children were like and what young children's development was like. And he kept very careful records of the development of his own children and had a whole bunch of interesting hypotheses about what it was that the children were thinking based on those observations. It's a sad story because potentially this science could have led to the origins of all of developmental psychology. But unfortunately, this scientist got kind of waylaid, and instead of continuing to do developmental psychology, instead he went out and started looking at worms and barnacles and things like that, the scientist in question being Charles Darwin. So very sadly for developmental psychology, but possibly good for the rest of science, he abandoned his potential wonderful stardom and contribution as the founder of developmental psychology and just became Charles Darwin, the founder of evolutionary theory instead. Yeah? The mic's up as much as it can be. It's up at the very top. I don't think I can. You might want to. There's lots of seats further down if you want to just come in closer. It's up as high as it can get without my holding it like this. And it's as high as this is loud as it can get. Okay. So we have some lovely, and hopefully this cold will go away sometime in the next year, and I'll be able to project a little more. Okay, so we have some lovely examples. We have some lovely examples in psychology, particularly looking at this question of children's understanding of belief. Of this kind of participant observation. In particular, there's a wonderful database called the Child as Database that was started by a bunch of linguists who were actually studying children's early language development. And what they did was just had records of all the things that children would say. And in fact, when I started out my career, that's what I did. My graduate work was going for the space of a year, every week, and just recording everything that these children said and then analyzing it. Not something I would recommend to any of my graduate students nowadays. The result is that you have this enormous database that just has everything that a bunch of these children said. And what you can do is you can search and analyze that database and try and use it to find examples, say, of children saying things that refer to their understanding of beliefs. Karen Barch and Henry Wellman actually went and did that. And they discovered some really interesting examples of children talking about false beliefs or differences in false beliefs. For instance, one of the vivid ones was that one of the children had been reading a book about vampires and said, oh, they thought the vampire was mean, but he was really nice. And there's another record where the child says, oh, I thought that was Daddy at the door, but it wasn't. So children are already talking about beliefs, what they think, or what other people think. So that's one way of keeping a record. Another technique, a psychologist named Marilyn Schaff took a tip from Darwin and actually kept a diary of her grandchild's development and looked at all the times when he talked about what he thought or what other people thought, and kept a record of that development. Now, the advantages of this kind of naturalistic observation, of course, is that it has high ecological validity. you're actually getting at, let me give you a nice example from Marilyn Schatz's diary. So when her grandson was about 3, he was wetting his bed all the time. And at one time, he woke up in the middle of the night and walked into Grandmom's room completely naked, having taken all of his jammies off. And she was convinced, oh no, he must have wet his bed. And she went in and actually, he hadn't wet his bed. And he turned to her and said, "You thought I wet the bed, didn't you?" So already, just in this naturalistic, and it's greatly to her credit as a developmental psychologist that at 2 a.m. dealing with a naked 2-year-old and a wet bed, she went instead and took notes about this because it was showing how smart the child was. Okay, so these studies have high ecological validity, but they also have some obvious drawbacks. There's not much control over what's going on in these studies. It's hard to measure everything that's going on, and it's hard to determine what is causal in these kinds of circumstances. So we can supplement naturalistic observations with experiments. And essentially, the idea is that with experiments, we create a situation where we manipulate just one variable to test its effect on just one other variable. So the independent variable is the thing that we're manipulating, and then the dependent variable is the thing that we're looking at. And that's a good way of trying to get a better sense of what's causing what. And an example of that, of course, is that false belief task, that task with the pencils and the candies that I just showed you. So that's a task that we can do with 3-year-olds and 4-year-olds across the world. We can do it over and over again. We can see if it's replicable. We can find out, is it just that Marilyn Schatz's grandson was incredibly brilliant, or is this something that we can see in children in general? And essentially what we do in that task is to just manipulate the information about whether someone saw the candies as pencils, and then we can see how the children respond in a consistent and replicable kind of way. Now, the cons of this is that the situations that we're doing the experiment in may lack ecological validity. So after all, we're bringing the child in, there's an experimenter who they don't know, we're asking just one question, we're assuming that the children are interpreting the question the way we think that they're interpreting the question, and they understand what's going on and so forth. And the false belief test is one example of such an experiment. One way that we can get over some of the restrictions of experiments is by actually trying to, and I think this is very, very important in developmental psychology, one way we can get over these restrictions is by trying to make sure that when we do an experiment, we have what people call convergent measures. So the trouble is that essentially any experiment that we can do in developmental psychology is susceptible to lots of different explanations. So for instance, take the example of the 3-year-old saying that there are, the other person will think that there are pencils in the box. Well, maybe that's because they don't really understand what's going on in the other person's mind, but maybe it's that they don't understand the question, or they don't understand what it is that we're trying to ask them. They think that we're really asking them about whether they know what's in the box. Or maybe it's just that they impulsively can't keep themselves from describing the reality as opposed to describing what the other person is thinking. And one way to deal with those kinds of problems is to see if children will have, say, similar things in very different kinds of tasks with very different kinds of structure. So, for example, in the history of understanding and false belief, one thing that we actually did in my lab was to ask not only what do you think what will the other person think is inside the box, but also what did you think was inside the box when you first saw it? So when you first saw the box, all closed up like this, what did you think was inside? And what we discovered was that 3-year-olds say not only that the other person, Nikki in the daycare, will think that there are pencils inside, they say they always thought that there were pencils inside. So even though they're actually really surprised when they see the pencils inside of the crayon box, if you ask them, they say, I always thought that there were pencils inside of the box. Another example is that you can ask children to tell you where it is that You can ask children to tell you about the contents of something like in that example of the Smarties box. You could also ask them what someone will think about the location of an object. So another classic version of this false belief test is to say, there's two children, Max and, sorry, can you know what's the name of the child? All right. Oh, Maxie and Moritz. This was actually originally done in Austria. So there's two children, Max and Moritz, and Max sees Moritz put a candy bar in the blue cupboard, and then Max goes out of the room, and while he's out of the room, Moritz puts it in the yellow cover, and now Max comes back. What will Max think? Will Max think that the candy is in the blue cupboard, or will he think that it's in the yellow cupboard? And where will he look? Will he look in the blue cupboard, or will he look in the yellow cupboard? Where will he look? All right, he saw it hidden in the blue cupboard, he walked out of the room, and then Tricky Moritz put it in the yellow cupboard. When he comes back, will he look in the blue cupboard or in the yellow cupboard? Good. Okay. Again, you guys are all over the age of 4. You ask that question to 3-year-olds, and they say that he'll look in the yellow cupboard. So we can use lots of different kinds of tasks with different kinds of structures to try to converge on a particular problem. Here's another important aspect of our doing experiments, and that is control conditions. So one of the things that I always say is if you want to really figure out whether an experiment is a good experiment or not, don't look at the test condition, look at the control conditions. The control conditions are really where all the work in developmental psychology takes place. So what's a control condition? In a control condition, what you want to do is keep everything the same about the task, except just the one variable that you think is most important. So, for example, in the Smarties and Pencils task, here was our control condition. So remember I said we say to the children, when you first saw this box all closed up like this, what did you think was inside it? So here's the control condition. Exactly the same experiment, but this time what we do is we actually show the children the box. The box is full of candies. We pour the candies out of the box. We put a bunch of pencils in the box. And now we say, what did you think was inside the box when you first saw it? Did you think there were pencils, or did you think there were candies? And what will someone else think was inside the box? Now, think about it. In that case, now I've actually taken the candies out and put pencils inside. If I ask you, what did you think was inside when you first saw the box? What you should say is, right, exactly. And that's exactly what 3-year-olds do. So if there's a real change in the box, if you've really changed it from candies to pencils, it isn't just that you thought that it was candies and it turns out to really be pencils. So if the question's about something that really happened in the world, not about your beliefs or your thoughts, then the 3-year-olds get it right. And what just that one control test shows you that when children are getting it wrong, it's not because they don't understand the language or that they can't remember what just happened. It can't be any of those other things. Because what you did was you kept everything exactly the same, the questions the same, the materials are the same. The only thing you manipulated is this about a real change in the world, or is this about just something about what you think or believe about the world? Is that clear to everybody, how the logic of that works? It's a little puzzle. Okay. So by having convergent validity and by having control conditions, you can get over some of the limitations of study. So let's do an explanation break. Turn to the person next to you, and maybe if you did the explaining last time, you might want to turn around and let the other person do the explaining this time. And say, under what circumstances, why would you choose an observational study versus an experimental? Anything I can do about let's go back again. I thought that was going to fix it, but we'll have to keep trying. Okay. Now, one of the things about developmental psychology is that we're studying development. So one of the things that we're really interested in is not just what's someone thinking at a particular moment or what's a kid thinking at a particular moment, but how is their thinking changing or how is their behavior changing? And there's a couple of different ways that we can address this question of how is behavior changing over time. So we can do a longitudinal study or a cross-sectional study or what's called a microgenetic study. In cross-sectional studies, which is kind of the most common way of trying to test development in children, what we can do is collect data from different aged children. So say when we do the false belief test, we might do it with 3-year-olds and 4-year-olds and 5-year-olds. And then see if there's a change between 3 and 4 and 5. And obviously that's the simplest and most straightforward way of doing experiments. That's what we usually do. But there's also some disadvantages of doing studies that way. We aren't necessarily mapping what each individual child is doing. We're only looking at the groups. And maybe, for all we know, say some of those 3-year-olds have really been solving the false belief test from the time they were 2, and we're just not getting it. So even though more of the 4-year-olds are solving it than the 3-year-olds, that doesn't necessarily prove that there aren't individual 3-year-olds who might have been solving it for a really long time. Right? So all we're seeing is that more 4-year-olds solve it than 3-year-olds. We don't really know what's happening with each individual child. And there's also the possibility that there's a lot of internal variability. So the children might be really different and they might be solving the task for really different reasons. And there's also the possibility of unknown confounding variables. So for instance, it might be that the 4-year-olds, it's not that the 4-year-olds understand the task better than the 3-year-olds. Maybe it's just that the 4-year-olds are better at using language than the 3-year-olds. Or the 4-year-olds are better at figuring out what the experimenter wants them to say than the 3-year-olds. So it's not really that they're conceptually better, it's just that they've got some other set of skills that are making a difference in this experiment. So another way to do these experiments is to do longitudinal studies. And in longitudinal studies, what you do is take the same group of children and measure them multiple times. So measure them, again, that's what I did for my thesis, come in 1 month and then come in a month later and give them the task again and come in a month later and give them the task again. And then actually see, here's a particular 3-year-old, what are they doing at 3, and then what are they doing gradually when they get to be 4 or 5. Or in some studies that we'll talk about in social development, you can even do this when people are 20 or 30 or 40 years later. There's a famous study actually at Berkeley, the Berkeley Longitudinal Study, where they're now looking at people who are in their 80s who they originally tested when they were a year old back in the 1930s. So longitudinal studies can extend for a really long time. And in fact, Henry Wellman and David Liu developed a scale of these different kinds of theory of mind tasks and then gave it to children and saw how their responses to the task changed over time. So the pro is there's less variability within subjects. You can actually see how each individual person, how each individual child is changing their minds. And you can detect things like whether there's just gradual change over a long period or whether, for instance, there's a very sudden change. Is it that children just slowly get better at doing this, or is there a point at which they can't do it at all and a point at which they do it all the time? Some of the cons are, obviously, this is harder to do, it's more expensive, and you have to deal with the possibility of attrition. So you can't necessarily get every child to come back every month. Children get colds and parents move away. And for some studies, for some of these really long-term longitudinal studies, like the Berkeley study I mentioned of the people where we study people for 80 years, there's the possibility of what are called cohort effects. So, for example, this is the kind of encouraging thought for people like me. For example, there are a lot of studies that show that we get stupider as we get older, right? So that as we get older, we can't remember things as well, and our intelligence changes, and it's just generally this dreary picture. But of course, the way they do those studies, that's the bad news. The good news is the way they do those studies is by saying, all right, let's study a bunch of 80-year-olds and look at their memory abilities, and we'll look at 30-year-olds, and we'll look at 18-year-olds. But of course, the 80-year-olds that you're studying now are people who grew up in the 1920s and 1930s. So they grew up with really different nutrition, with really different schooling. There's lots of things that make them different from, say, a 20-year-old. And there's some evidence that when you do longitudinal studies, take the same group of people and look at them between the ages of 50 and 60 and 70, you see much less cognitive decline. So part of it is that you're looking at people growing up in the 30s, not having as much education, and generally not having as much of an opportunity to practice their cognitive abilities, versus people who grew up in the 60s or 70s or 80s who had much better opportunities. That's an example of a cohort effect. So it's not really that you're showing that things change, you're showing that one generation is different from the preceding generation. Is that clear to everybody? And a last example is that you can actually study development in a very short period of time, especially when children are just in the midst of one of these developmental transitions. So, for example, something that we did in my lab is take children who can't solve that false belief test yet, those 3-year-olds, and then look at them every week. So every week we can give them the test, and we could also give them some information about false belief and see how week after week their ideas about false belief change, or see if we can get them to solve the problem more quickly if we give them certain kinds of experiences rather than other kinds. So a microgenetic study is like a little mini longitudinal study. We're just looking just at the time when we think that something is changing developmentally, and then looking very, very carefully at what the children are doing in that short period of a developmental transition. Is that clear to everybody? Okay, I think we'll skip the second explanation break because we have more to do. Now, another way that we can try to solve problems is by looking at atypical populations. So far we've been talking about just, your typical children who are the kind of children we'd see in the Child Study Center daycare. And we can just go in and see, well, what do those children do on these false belief tests? But actually, it's often very illuminating to look at children who are not developing in a typical way. And in this particular case, this case of trying to understand when children understand other people's minds, there's 2 atypical populations that have turned out to be really interesting and illuminating. And of course, part of the reason why we study atypical populations is because we're interested in therapy. We want to see how we can help children to develop better. But often, atypical populations can tell us things about basic scientific questions that we have about why it is that particular kinds of developments are taking place. So the 2 examples in theory of mind are autism and deafness. How many people here have read this book, The Curious Incident of the Dog in the Nighttime? It's a fantastic book. I highly recommend it. It's a wonderful book. It's about a young man with autism, and it's written from the first person. So it gives you a sense of what his experience is like as someone with autism. And it was a kind of fascinating thing for me to read, because in the midst of reading this wonderful novel about the child with autism, at one point the therapist comes in, and the therapist actually gives the protagonist our Smarties and Pencils test. So it's sort of like, oh, wait a minute, that's my experiment, suddenly showing up in the midst of a novel. So the child says yes, and then the therapist took a box of pencils and opened it up, took a box and opened it up, and there were pencils inside, and she asked me what I had thought that was in the box and what someone else would think was in the box. And the reason for that is because, in fact, it turns out that very characteristically, children with autism are very bad at solving these kinds of tasks, very bad at trying to take the perspective of another person. And whereas typically developing children will solve this task when they're 4, children with autism may not solve it until they're 12 or 13. Even high-functioning children with autism will otherwise have normal intelligence. And if you think about people with autism in general, we know that a lot of their difficulties come because they have a hard time understanding, socially interacting with other people and understanding what's going on in other people's minds. And very, very early on in this process, we discovered that people with autism seem to have these very specific kinds of deficits, very specific difficulties in understanding what was going on in other people's minds. And that suggests, since we know that autism is a congenital disease, it's something strange that happens with your brain development in utero or very early in development, that suggests that there's something innate, there's something about the way that typically developing children's brains work that enable them to understand what's going on with other people. And somehow those brain capacities are getting damaged or changed or interfered with for children with autism. And of course that also suggests things about therapies we might try if we actually could teach children with autism to understand what's going on in other people's minds. Maybe that would help to solve some of these problems help to solve some of their problems with social interaction with other people. And in fact, this has come to be one of the main therapeutic approaches that people have taken to trying to help people with autism, especially high-functioning people with autism. Another example of of an illuminating study with atypical development involves deaf children. So very interesting and unexpected development that we found early on was that children who backtrack. So some deaf children of deaf parents learn how to use sign language from the time they're born. And we know that deaf children learn sign language just the way that hearing children learn spoken language. They're very good at doing it. It happens very spontaneously and very naturally. But of course, most deaf children aren't born to deaf parents. Most deaf children are actually born to hearing parents. And that means that those children need to actually learn sign language. And there's a lot of variability in how much and how early those children actually do learn sign language. And there are still places in the world where they discourage deaf children from learning sign language, where they try to insist that deaf children learn spoken language instead. I think that's increasingly not happening, but there's still populations of deaf children who are not really learning how to sign early on in their lives. When they went to do theory of mind tasks with these children, what they found was that the deaf children who learned to use sign language from the time they were very young looked just like typically developing children. 3-year-olds had trouble with the false belief task, but 5-year-olds were really good at it. But when they looked at the deaf children who hadn't had sign language experience, the deaf children who hadn't been taught sign, then they saw a very different picture. And those children, even though intellectually they were just as developed as typical children, looked more like the children with autism. So those children weren't solving these false belief tasks until very, very late in development, sometimes even 9 or 10 or 11 years old. So the children, there seemed to be something about language and communication that was playing a really important role in children's ability to understand what was going on in other people's minds. And there was an even more elegant study, which in fact one of my students, Jenny Pyers, actually did here at Berkeley. And this is a really fascinating story. In Nicaragua, until the 1980s, there weren't any schools for the deaf in which children would be taught sign language. So what happened was that individual children who were deaf would kind of try to cobble together some communication systems for themselves out in their own houses, but there wasn't any central place where deaf children could learn sign language. And then what happened was that the government decided, this is terrible, we need to have communities where children can actually learn how to use sign, or deaf children can actually learn how to use sign. So they started teaching children sign, and the children started going to the schools. And what that meant was that there were two generations of deaf people in Nicaragua. There was the first generation who hadn't gotten sign language, and then there was the second generation who had learned sign language. And what Jenny discovered was that when you gave these false belief tests to deaf people in Nicaragua, even though the first generation was actually older, the older people who hadn't learned sign had much more difficulty solving the task than much younger children who had learned sign. So actually introducing the sign language into this community seemed to have made the difference in whether or not people could understand what was going on in other people's heads. And this first generation, which included people who were in their 20s or 30s, still were sort of clueless about what was happening with other people. And in fact, the younger generation of deaf people said, yeah, you have to be really careful when you're talking to the older people because they just don't get it about things like what's happening in other people's minds. And a final example of a technique that we can use. So far, we've been talking about just studying children in our culture, in North American middle-class culture, and that's usually mostly what we do. But of course, that's a tiny percentage of all the children that you could test in the world. And in fact, there's been something of a movement in psychology to avoid what a couple of cross-cultural psychologists call weird people. Weird stands for white, educated, industrial, and developed. So what they say is almost all of our knowledge of psychology comes from this really, really weird group of people, this group of people who are not representative of human beings in general. And we have to stop testing the weird people and look at, like, normal people. So let me give you two examples of the ways that this kind of cross-cultural studies can be illuminating. Paul Harris, who's a developmental psychologist, actually went and looked at the Baka people. These are people in Africa who are still leading a kind of hunter-gatherer / simple agricultural kind of life. And he went to actually test false belief with these children. Now, there's some interesting challenges when you want to do this kind of cross-cultural work. The first challenge was that he wanted to try to get the local grown-ups to do the testing because the children were very shy about having people who weren't local grown-ups. But he discovered because the local grown-ups weren't literate, when they asked the questions, they'd ask the questions differently each time with each child. So the idea of actually having a script that was exactly the same each time was something that pre-literate people just couldn't understand, couldn't make any kind of sense of. So that was one challenge. Another challenge was that they didn't really have boxes in this culture. So there were very, very few examples of things like boxes. You just take for granted the fact that we have boxes. They didn't have very many cupboards. They didn't have much furniture. So what they did was they actually took a particular kind of nut that everybody really likes that has a delicious center inside of it. And then they doctored the nut so that they had the outside hole of the nut, but they didn't actually have the delicious nut in the middle. And then they asked the children, what will someone think is inside of this nut when they see it? Will they think it has the delicious middle in it, or will they think that it's empty? And then they saw that it was actually empty. And then the last challenge was that they couldn't figure out whether the children were 3 or 4 years old because nobody kept track of how old the children were. So it turned out that fortunately there had been a dramatic event where one of the chieftains in the tribe had been poisoned that had happened about 3 years ago. So what they could do is say, all right, now could you tell me I'm going to have all the children who were born before the chieftain was poisoned and all the children who were born after the children the chieftain was poisoned. So with this kind of heroic work, the bottom line on this is, after they'd done all this work, it turned out that these children looked exactly like the children in California or in London. The 3-year-olds, the ones who were born after the chieftain was poisoned, said that everybody would think that there was nothing in the delicious nut, even when they'd seen it all closed up like this. And the 4-year-olds, the ones who'd been born before the chieftain was poisoned, said, oh no, if he sees it, he'll think that there's a delicious nut inside, and actually there really isn't actually the delicious nut empty. So that's an example where a cross-cultural study actually led people to think, well, there's something similar. But Henry Wellman and Twyla Tardif looked at these theory of mind developments in China, and they discovered that although some of the developments were similar, there were other kinds of tasks where there were actually differences between the development of children in China and the development of children in the United States. So, for example, understanding knowledge, understanding your skills and abilities was something that children in China actually developed before children in the United States. And they thought this had something to do with the Chinese education system. So sometimes cross-cultural studies can tell you this looks to be universal, and sometimes it can tell you that there are actually important and significant differences. Okay.